All right, so with this bell work, we are looking at a bunch of these uh, piecewise functions. These are sometimes called step functions and things like that. This is stuff you definitely talked about in Algebra 1. And what you can do here is, what makes this one a little more difficult is that you have this big paragraph, you have to parse through a lot of information, but some of the information is not important. And so really the important sentence comes right here. The graphs below show the one passenger fares in dollars for both cab companies for trips up to 6 miles. So, and then it says basically when these two companies are compared, which is cheaper for 5 miles. So, in essence, that entire paragraph is saying, look at these two graphs and figure out which is cheaper for 2 miles, or for 5 miles. I'm sorry. So, 5 miles would be right here and right here, respectively, for these two graphs. Now, remember, part of this is just the notation from these graphs. So when you have an open circle, you should remember this from Algebra 1. An open circle means that that particular data point is not part of the that data set, if you want to think of it that way. But this line right here does not include 5. It goes from 4 up to 5, but not including it. And then this one right here starts at 5 and works its way up to 5.999, So there we go. So it turns out that the data point 5 is in this line that I've circled. And so when I come over here, that's 12. So it costs $12 for ABC cabs. Now right here, the same thing going on. It's not part of this, but it's part of this line segment. And now when I project that one over, I get $9. So $9 is the fare for this. So basically, what is the cheaper fare? Well, the cheaper fare is this $9. And there's our answer. So the answer is B, or G in this case. Okay, and that's pretty much what, the key thing here is remembering that that open circle means that it is not including that data point. Okay, so you're going to start, and part of your assignment today is going to be simplifying radicals, but it's not going to be guided anymore. Now it's just going to, well, that's funny. I'm going to get a new problem. Okay, let's go with this one. Okay, so this is no longer guided. It doesn't tell you what to do in order to solve this, but it's still the same basic type of problem that you've been working on with past assignments. So what I want to do is I want to find the biggest perfect square factor of this number 192. Okay, so the first thing I can do is think of what my perfect squares are. And so if you don't have those memorized, we can kind of run through them a little bit, but up to, I'll just do that far. So those are some perfect square factors. And one thing that I could try, if I have a calculator, I could try different numbers to see, is that a perfect square factor? Yes, it is. So if I go through and do this, what I can find, sorry, I'm kind of losing my train of thought as I'm going. I might try 16. Now I could start with 4. I could work my way up. Maybe I could try 9 and 16. But if I do 192 divided by 16, I see that that is the same as 16 times 12. And so I'm just going to rewrite this as the square root of 16 times 12. And I know that the square root of 16, I can just pull that out of the square root. So the square root of 16 is 4, which makes this 4 square root of 12. But when I look at what's left over under the radical, I can see that there's more perfect square, there's another perfect square factor. So I'm going to rewrite this now as 4 times the square root of 4 times 3. Okay, and now I can pull the square root of 4 out because I know the square root of 4 is just 2, which makes this 4 times 2 times the square root of 3. So if this isn't making sense, I'm not going through it very quickly, or I'm not going through it very in detail. I am doing it a bit quickly. But knowing that this square root of 4 can be pulled out and turn into just the whole number 2, Now I can just do 4 times 2 right here to give me 8 times the square root of 3. All right, so let's say you come up with that and you plug it in and you get the right answer. That's all well and good. If you don't get the right answer, regardless of what happens, so let's see, that was the right answer. Check mark right there. But you can see the process for that right here. So it runs through it again. So if you forgot, you'll have a chance to see how it's done, and it puts it in plain English for you, gives you the steps along the way. So anyways, you'll have 5 problems of that. And if you have any questions with it, you can certainly ask me. If you want to run through some more of those, we can do that before you log off today. I wanted to go back. Okay, the other part, you have some equations to solve. One of them is going to be, actually, I don't want to do that one yet. I wanted to look at, no, let's do that one, sorry. So you do have this kind of problem where now notice that you have variables on the left, variable on the right, number on the left, number on the right, and they're all going to have that same format. Now, the reason we're doing some more practice is because our next unit that we're starting on Tuesday, we will be doing a lot of work with equations, and you need to be comfortable with that part of it, because that shouldn't be the difficult part of the math that we're about to do. All right, anyways, what I want to do is I want to get all of my variables on one side and all my numbers on the other. So I've got a number right here, a variable right there, a variable right there, and a number. So let's move these numbers over. Maybe the way I want to approach this is I want to subtract 5 from right here. So I'll write this over on the other side. The 5 cancels out. Now I get negative 15x equals negative 10x. 25 minus 5 is just 20, so plus 20. Okay, now I want to move this over to the other side, so I'm going to add 10x. And hopefully most of you are saying, yeah, I know exactly what to do for this problem. I don't need any help, because this is not new math that we're learning today. So negative 15x plus 10x gives me negative 5x. All we're doing is basically doing the negative 15 plus 10, and then whatever that is, it's in front of an x, okay? So that's equals 20 as well. So now I get negative 5x equals 20, and I want to get the x by itself, so I'm going to divide by negative 5. And when I do that, I get x equals negative 4. Because these are different signs, when I divide them, the quotient is going to be negative. If they were both positive or if they were both negative, I'd get a positive quotient. All right, now keep in mind, and I might remind you of this again, we can always check this answer by just plugging it right back in for x right here. So if and I'm not going to do that right here, but if I plugged in negative 15 times negative 4 plus 5 equals negative 10 times negative 4 plus 25, I should get that to work out. I'm just going to try my answer because I feel confident that I did it correctly. And I did. And if I didn't do it right, it would give me kind of the steps for how to do it. It's important that you use these steps to kind of learn where your mistake was. Okay, last little bit is going to be these types of problems. Now we're also going to have some equations coming up where you're going to have a bunch of stuff on one side, all equals one number on the other. So these are good problems to practice with. And I'm going to go ahead and copy this problem over here. Negative 4 times negative 2x plus 5 minus 5x plus 5 equals negative 24. So this looks complicated. Now the first thing I want to do is I want to use my distributive property so that I can start to combine my like terms. So I want to do the distributive property. Negative 4 gets multiplied by negative 2x, which makes it positive 8x. Negative 4 gets multiplied by positive 5 to make it negative 20. 4 times 5 is 20, but the positive and the negative makes it a negative product. Minus 5x, this is just carried down from above. So all I've done so far is the distributive property. Now I can combine like terms. I've got 2 variable terms. I've got two number terms. So if I combine my variable terms, 8x minus 5x gives me 3x. Negative 20 plus 5 gives me minus 15. All right, now we're ready to do, at this point, it's a pretty straightforward equation. So I'm going to get rid of the 15. I'm going to add 15 to both sides. And that gives me 3x equals, and this might be a little bit confusing if you have negative 24 plus 15. We've already done some integer addition with positives and negatives, but just, again, I've told you this before, but if here's 0, one thing that I like to think about is if my negative 24 is my starting point, then plus 15 means I'm going to go right 15. And that puts me, if it's helpful to actually visualize a number line, you might find that good to do. That moves me up to negative, wait, it's negative 24, sorry. It might be helpful to do that so that you can see where your answer is going to end up. So this is going to end up at negative 9. So now I can just divide by 3 to get x equals negative 9 divided by 3. We get negative 3 as our quotient right there. And again, I can just plug this back in up here into that x, and then I can go through and evaluate what that would be, make sure it all checks out. Here, I'll just plug in the negative 3. And I got the green check mark. I did it right. But even if I kind of guessed on part of it, I can double check to see, make sure that everything I did was correct. Or whatever I didn't do that was correct, I can correct it here at this point. Okay. So if you are good to go, if you feel like you understand all the stuff that you're expected to practice, then you can have a wonderful weekend. I expect you to go and practice that right away, but you don't need to hang out. You can log off. Have a wonderful weekend. If you have any questions, please hang out.
Thank you.